Here we are back in the Physics Nightclub for talking about some AC. That is on 06i for summer 2018, question 4.1, and we're on question 6, boringly. Okay, we're generating some AC electricity, as I mentioned before, and we're being asked to think of the things that must be in an electrical generator. Now, let's just go through each one. An ammeter might be useful, all right, because you might want to know the current that you're generating. However, keyword here is must. Yeah, keyword here is must. You don't need an ammeter. It's just an additional thing which might allow you to know a little bit more about the current that you're generating. A battery. Well, if we had a battery, I would suggest you don't need a generator then. Right? If you've got a battery already, then you've got the electricity. Okay, you do not need that. Light bulb, also no. Why not? Well, because that doesn't create the electricity. It allows us to use the electricity. So we would talk about in a generator, we talk about an EMF, the electromotive force, the amount of energy generated. Okay. However, a light bulb would be more about a potential difference, be more about the energy used. Magnet, absolutely. We need a magnet and we need a magnetic field, right? The whole point about an electricity generator is that it uses magnetic fields to generate electricity. Again, just like the ammeter, the voltmeter would give us extra information. And lastly, process of elimination, you need to do 2. Don't ever tick 1 or 3 here because the keyword is 2 here. Yeah. Well, we need a wire coil. The wire coil is the thing which is going to do the carrying of the electricity. Okay. Recent topic for us. Okay, just at the end, we talked about when we're generating electricity, we have a step-up transformer which increases our voltage. Okay. Why the voltage is increased? Well, we step it up, which means that the current goes down. All right. Remember, we had the idea of if we have an input, our secondary coil and our primary coil. Yeah. Oh, sorry, I'll tell you what, I'll reverse this. Primary and secondary. Okay, primary after secondary. Well, the formula for power in an electric circuit was current times voltage. Okay, so we could talk about the current and voltage in the secondary coil and the current and voltage in the primary coil. Now, if we're stepping up, V must increase. Yeah. So if V goes up, in order for this to be true, I must go down. Okay. And the result of that is the power lost also goes down as well. So here's our idea. We step up the voltage, we step down the current, and therefore step down the energy losses in the wire. All right. We've got the output from the wind turbine. This is the wind turbine is connected to the primary coil, okay, of my transformer, and it's then stepped up. Number of turns on the primary coil is 28,000, so that's our NP. 440,000 on NS, and then we're asked to calculate the formula. Let's calculate the output voltage VS. Okay, so be careful. They're not explicitly asking for secondary voltage and primary voltage here, but you're expected to understand that the turbine is connected to the primary coil and the output is given on the secondary coil. The equation we're going to use here is this one. Yeah, that's the one that we need.